Hello champs, today we are going to discuss about yet another interesting topic, and that is understanding motion. Motion everywhere, not even a single object at rest. And so motion is the lifeline of this universe. Everything in this universe is made up of those restless tiny atoms. Inside the atom, you find electrons which are moving at very high speeds around the central nucleus. Now, be it the atoms, the molecules, the planets, the stars, the galaxies, all of them are in motion. And time is the real ruler of this universe. Time never stops. So the objects which came into being with time, they cannot stop either. True or not? Right. And that's why we say that motion is the order of this universe. Time is the ruler and motion is the order of this universe. Now, the Big Bang, which occurred between 12 and 14 billion years ago, since then, the universe is expanding. And what I mean by that is that it is in motion. Though you cannot perceive the whole universe at one go, but whatever you see is a part of the universe. True or not? Whatever you're seeing is a part of the universe? Right. Now, I have a question for you all. How do you normally perceive an object to be in motion? When do you say that the object is in motion? Okay, so an object is said to be in motion when its position, it changes with what? With time, right? So when we say that the object was there, but now it is not there, say the car is initially at position A, but now it is not at the same position, it has moved. So what would you say? That the car has moved from there, and in this case the car moved from position A to position B, and so the position of the car changed with time, and thus we call the car to be in motion. Now, what do you call an object if its position does not change with time? Come on, I want an answer from you now. What do you call an object whose position does not change with time? Yes, you would say that the object is at rest, as it remains at the same point even with the change in time. And so the position of the car, it remains static with change in time. Now it appears that defining motion is quite an easy task. What do you think? Is it an easy task, defining motion? Actually, it is not so easy. And you'll be surprised to know that a body which appears to be at rest for one person, the same body, it may appear to be moving to another person, and vice versa. Very strange, right? But very true as well. Now let's take an example. When you walk into a mall, you stand on an escalator to go from the ground floor to the first floor. So you would say that you are at rest because it's the escalator which is moving while you are still standing there. But what will the other person say who's standing on the ground? He will say, "Oh, see, that man is moving." So with respect to his view, you are in what? You are in motion. Now I'm going to take some more interesting examples to make this concept of motion even more clear. So you're in a moving train and you look outside. So what do you see when you look outside the train? The moving train? Yes, you will see that there are trees or there are fields and poles which appear to be moving to you. So now the question is, are they actually moving? Just think about it for a moment. So when you're inside the train, you see the objects outside the train to be moving. And what do we see when we are outside the train? Well, in this case, you would say that we see the train to be moving. Now the train is moving, right? Okay, let's take another example. So here's a car which is moving on the road. Now you can see that the tire of the car, the tire of the moving car, it is rotating about its axle. And there is also a mark on the tire. Now this mark, it remains as it is on the tire. But the question now becomes, how does it appear to the observer who's standing on the road? And to an observer who's standing on the road, it appears to move in a cycloidal motion. So for a person who's standing on the road, this mark on the tire, it would appear to move in the cycloidal motion. Now let's take another example. So when a body it is dropped from a moving aeroplane, then how does its path differ with respect to the pilot and with respect to the person on the ground? The path of the same body which is thrown from the aircraft. So the path of the body with respect to the pilot is a straight line, while the path of the body with respect to a person who's there on the ground is a parabola. Now again the question arises, why does this occur? The same body appearing as straight line to one person and it appearing as a parabola to another person? Now that's because the path of the body with respect to the pilot is a straight line, because with respect to the pilot, the body just has one component of velocity, which is acting in vertically downward direction. But with respect to the person who's there on the ground, the body it appears to move in a parabola. And that's because with respect to that person on the ground, the body now has two components of velocity, the horizontal component and the vertical component. So it has two components, and that's why the resultant is a parabolic motion. So you know, what we know and what we perceive, they can be quite conflicting at times. Now let's take another example and see how this conflict takes place. So you're sitting on the earth, but then you cannot see the earth moving around the sun. Rather we say that the sun is moving, and as goes the common saying that the sun rises in the east and sets in the west. But now the question is, when the earth is moving, then why don't we directly perceive the motion of the earth? And to understand this concept, we must be aware about the heliocentric concept. How many of you know about the heliocentric concept? Or if you have heard of it earlier? Okay, so let's explore this concept, what this concept says. So firstly, this concept of this heliocentric concept, this was given by a very famous scientist, Copernicus. But before Copernicus gave this heliocentric concept, which we'll just discuss, the ancient scientists, they believed in the geocentric system. And geocentric system is a system in which the earth is assumed to be at the center of all. While all the moons, the planets and the sun, all of them, they appear to be moving around the earth. Now, do you think it is actually true? The moon, the stars, the planets, they're actually moving around the earth? Well, the answer is no, because all of us know that the planets, they revolve around the sun and not around the earth. And precisely this is known as the heliocentric concept, in which the sun is at the center, while all the planets, they revolve around the sun. But then this doesn't mean that the sun is at rest. That is, if we were to see the sun along the solar system in our Milky Way galaxy, then we will notice that even the sun is moving. And now you'd be saying, then so who's really moving and who's not moving? You say the sun is at rest, and the other moment you say the sun is moving. So what's actually happening? What's actually moving and what's not moving? So far, all the examples that we've discussed in this particular module, did you find any common peculiarity? Any common thing in all the examples that we have discussed so far in this module? Yes, there was. In all the cases that we have discussed, our observation was based on the fact that we assumed ourselves to be at rest. So we say that we are at rest. Whether it was in the moving train or it was standing on a road, we assumed that we are at rest. Now from one's point of view, a body is at rest. But from the other's point of view, the same body is in motion. And let's understand this by taking one more example. So here you are sitting in a train, it's moving, the train is moving, and you're sitting inside it, and there's a person who's sitting in front of you in the same train. Now, how will that person appear to you? Well, you would simply say that the person is at rest. Now, there's another person who's sitting outside the train on some platform. And if I pose the same question to him, then what will be his answer? Now he will say that the person who's sitting in front of me, he's moving, he's in motion. So what can you conclude from the knowledge that you've gained so far about motion? We've concluded that an object may appear to be moving for one person, and the same object, it may appear to be at rest or stationary for the other person. And trust me friends, motion does not make any sense unless it is mentioned according to whom. You take any example, but according to whom is something which you need to mention. And so I say motion does not exist without a point of view. And the technical term which is used for it is called the frame of reference. So when you're standing on the ground becomes your frame of reference, and anything that now you're going to see or you're going to watch or even measure, that will be compared to the reference point on the ground. Now tell me something, what will happen if your frame of reference is a moving truck? What will happen? Okay, first tell me, if you're in a moving truck, then what becomes your frame of reference? The moving truck? Okay. And if the moving truck becomes your frame of reference, then what will happen? All the measurements that you're going to take? Exactly, that will be as compared to the truck. But you know, there is no fixed frame of reference. There's no absolute frame of reference. And so, some frame of reference must be chosen arbitrarily. And in majority of the cases, while we are dealing with motion, we take Earth as the frame of reference. So the Earth is taken as a stationary object and we define it as the frame of reference. And trust me friends, it is not that the Earth is a perfect frame of reference and that's why we have chosen it. But you know, for many purposes, it is good enough, and that's why we have arbitrarily chosen it. And also the frame defined by the Earth, it is often easy to work with. And actually all the motions are relative, since an arbitrary set of axes or planes is required to define the motion. Now the Earth is accepted as a fixed reference plane, and all the motions relative to it are termed as absolute motions. So whenever we say that a body is in motion or it is at rest, then definitely it is with respect to what? Which frame of reference? The frame of reference that we have chosen, that is Earth. So the motion or the state of rest is with respect to Earth. So with this, we come to the end of this particular module. I am sure you would have loved this module and you would have, gained more insight into the basic concepts of motion. So stay tuned for the upcoming modules. Until that time, keep learning and keep revising whatever you are learning. Okay? Okay, have a great day ahead. Keep enjoying. Thank you.